Hi there, this is video U 3.16. So 315 was the lab where you cut out the triangles and taped them together on the lab sheet to show that the sum of the interior angles of a triangle is 180 degrees. And that was inductive reasoning, because you did a sample and you did another sample and you came out the same, and you kind of said, well, you know, odds are pretty good every time I do this, it's going to work out the same. Now we're going to do a geometric proof, two-column proof like we did before. And it's deductive reasoning, because once we do it, it will be the same and we don't have to repeat it because it's a mathematical proof. Before we do anything else, I'm just going to extend my lines. Like that. I don't know, it makes it easier for me. It makes it look more like a transversal. If the transversal doesn't go outside the line, my brain goes, what's going on? I'm also going to 1, 2, 3, 4, 5, 6, 7. I'm going to label my angles just to make it easier. Rather than have to talk about angle P, D, R, I can just say angle 1. And I find that a whole lot easier. All right, so we got our statement and our given. So basically what we're trying to prove is angle 2 plus 5 plus 6 is equal to 180 degrees. I'm going to write that. Angle 2, angle 5 plus angle 6. Well, now this is a key here. We're looking at 180 degrees. So where do we have 180 degrees in our diagram? Well, I have it here and here. But my other hint is I have 3 angles there. Look right here. I got 3 angles up there that are equal to 180 degrees. And I think that's going to be our starting point. Because I know, I cover up this part of my diagram, angle 1 and angle 5 are the same. And if I look at this part of the diagram, angle 3 and angle 6 are the same. So I should be able to go 2 plus 5 plus 6 is 180. We should get there. So angle 1, angle 2, angle 3. Oh, I did not leave myself enough room. It is 180 degrees. Why? Because they form a straight line. They are supplementary. Now let's see if we can do some replacements. Because angle 2 is good. I care about angle 2. But I don't really want to know about angle 1 because that's not an interior angle, but angle 5 is. So angle 1 is equal to angle 5. Because they are, right, if I only look at this part, they are alternate interior angles. Are equal. Right? And we know, I guess we should look at that PQ and RE are parallel. The lines are parallel, we're good. So now I've been able to talk about angle 5. Now we want to talk about angle 6. Because we want that included. There's a relationship. Angle 3 is equal to angle 6. And you know what? It is exactly the same reason. Now, what I want to prove is angle 1 and 2 and 3. So instead of angle 1, I'm going to write angle 5. Angle 2, leaving where it is. and angle 3 instead of angle 3. Angle 3 is the same as 6. And that is substitution. So this proves the interior angles we're done. The interior angles of an angle add up to, of a triangle add up to 180 degrees. See, the point is when you do the indirect proofs, you don't know if somewhere out there is some crazy triangle when you cut off the corners and tape them together, it doesn't work. But this one, we never actually said how big these angles were. So I could have another set and it could be like really, oh goodness, it would have been better if it was a straight line. Okay, I could make it a much fatter one, and then but the rules are still the same. All I would have to do is renumber the diagram, and it's going to be exactly the same every single time. So it's deductive reasoning. Oh, why is this deductive reasoning? Because it works. It is a general case. That works. For every triangle. It's a mathematical proof. This last little rule here, and literally I wrote it there. It's nice to know, but you can really work around it. It says the exterior angle is equal to the sum of the angles on the other two sides. So this angle D here is equal to A plus B, which I guess basically now that I look at it, it's exactly the same diagram, just written backwards. I think this one's going to be missing when you can see your sheet because it's the same picture. It's easy to do, but the truth is you can always talk about the fact that D plus this one is supplementary, and then these guys are supplementary, and it works out to be the same. Here, I'll show you what I mean. So we'll call this angle E. See, this is like a mini proof. I'm not going to get all formal on you, mostly because there's not enough room here. So angle D plus angle E, right? E is the one I just threw in there, is equal to 180 degrees. That's supplementary. Angle A plus angle B, whoopsies, plus angle E, 180. Interior angles of a triangle. So then angle D plus angle E is equal to angle A plus angle B plus angle E. All right, what's the reason there? Yeah, you know, I could agree with substitution, or you could call it transitive because this is equal to 180 and this is equal to 180. So then these two things must be equal to each other. And then I'm going to subtract angle E, subtract angle E from both sides. And that is literally just subtraction. So there's the mini proof that goes with that. It's up to you whether you really worry about remembering that. What's key to remembering is that anytime you have a nice semicircle, it's 180 degrees. And for the next little bit, most importantly, the sum of the interior angles of a triangle is 180 degrees.